All right, moving on to 8.2, we're going to talk about similarity of polygons. So which of the following polygons look similar? And just kind of on your intuition, which ones look similar to you guys? And if you're zeroing in on this middle set, that's the pair that looks similar. And without knowing what the definition of similar means, hopefully that's the one that, yeah, I would say those look similar to each other. So let's figure out what similar means, and then we'll go back and talk about why these other two are not similar. So similar polygons. For two figures to be similar, and here's our little, our little symbol for that. So it's kind of like, you know how we have a congruency symbol? It's that top little squiggly. That's what we use to denote similar. So for two figures to be similar, the following must be true. So the first one is the ratios of the measures of corresponding sides are equal. So kind of what that means is if you take, let's say you take a figure and let's say these all have a side length 2 and then these all have a side length of 8. And we'll get more into finding, the ratios, but you can see that each side was multiplied by 4 to get to the side. That's consistent with every side of the polygon, so that means that the ratios of the measures are equal. All right, corresponding angles are congruent. So you're going to have the same angle measure. If you notice up here in our example, we had right angles in both figures, or what appeared to be right angles. I guess we don't know positively, we can't assume that. All right, so if you look at this example over here, we have a circle, and then basically it changed shape and became an oval. Those two figures are not similar. The idea of a similar figure is if you take a shape and you either make it bigger or smaller and it doesn't change shapes at all, then they are similar. These triangles over here, notice how this one looks kind of like a right angle. You don't have anything over here to match that angle, so these are not similar either.